Hi, hello. Welcome to AUTOMAT streaming. Sorry, live coding. I've been doing some work on AUTOMAT in the yesterday and the day before after stream, and I managed to move this onto Windows, so now we have a working Windows build again. It's not free of bugs, so to say. I've added some new debug tools so that we can better understand what's happening. So one big new thing is, hey. Okay, so this stuff is going to be hard to see, but we have this bullseye, right, on screen. Now, this is for latency visualization. So when I move my mouse, just before, so when I render a frame, just before I present the Vulkan surface to the screen, I take the current mouse position and I draw a bullseye there. So this shows us the upper limit of how fast we can render stuff close to mouse. So you can see that when I move the mouse, if you look very closely, the mouse doesn't really always touch the center of the bullseye. Sometimes it goes in the orange area, sometimes when I move the mouse fast, it goes in the red area, and sometimes the bullseye just stays behind, like a long way behind.
Capsero says,
So the bullseye is the optimistic case. This is something we can fix because we have our own code for vsync. So we are not using the system provided vsync. We have our own in Vulkan. Anyway, there was a bit of code here somewhere, I don't remember where it was. There was a bit of code that actually waits a bit of time before giving us the next surface. Or maybe it's in Windows, never mind. So I think this delay between the bullseye and the mouse position, I think it still can be minimized. We can still improve it a little bit. I don't know. Oh, I actually know. So there are those long lags, right? When the bullseye stays in place. This is actually because of Windows Terminal. So Windows has a very badly optimized terminal implementation. When you actually print something here, it blocks the application until printing finished. And the terminal is kind of slow. So the printing on Windows executes in lockstep with the terminal presentation logic. That is interesting. Okay. So there is, this is one type of lag. There are more types of lags. So I've designed the bullseye so that it's transparent in the center. So when I grab a mouse object and I move it side to side, you can see that the center of the bullseye leaves the mouse. This is because our implementation is kind of multi-threaded, and this distance between the bullseye and whatever I grabbed is actually, so this latency is coming from kind of multi-threading. Because we are first taking the position of the object, then starting the rendering, and then we are throwing the bullseye a couple microseconds later. So there is a couple pixel difference. It's not large, even when I move my mouse very fast, that difference is not super high, but it's there. There is one more lag, the connections. The connections are lagging behind the mouse, and this is the bug in our code. We just need to properly update the bounds of the texture so that the connection stays attached to the object that it should be attached to. So now we have a pretty good visualization of three kinds of lag. First, there is the presentation lag. This is the lag between cursor and the bullseye. There is the kind of multi-threading lag. Maybe there is a way to minimize this still, which is between the bullseye and whatever I grab. And there is the lag between the object and the connections, which is, this is the heaviest one. This is the most visible one. Maybe we'll fix this today.
Yep. There you text for summary.
And I think we can... So Windows build actually has slightly different... So the Vulkan and the rendering pipeline on Windows is slightly different than the Linux version. Because on Linux we are reusing the main thread, the application thread, to do rendering. On Windows we have a completely separate thread for rendering, which should be better, but it introduces more kinds of lags. So on Linux some things may seem simpler, but I don't fully know. Okay, I will see if I can push this.
Tatevo says,
Balloon Cheshire Bill.
Hey, hello. Hello back. I probably have some uncommitted changes in here. Yeah, I do. Let me discard this. Something like that, maybe. Okay. This is not a bare Git repository.
Capsaro says,
Chase, Jordan. Okay, now I should be able to push.
Yeah, moving stuff between local machines is... Git makes it so easy. When I was developing on Windows, some of the Linux files got broken. This usually happens. Okay, now we have a bullseye. On Linux I have a much better capture card, so the latency here is more visible between bullseye and mouse. Yeah. Okay, I will fix all of that, but I am not going to do this in VS Code. I will use cursor, because I recently checked and it turned out that cursor has a 2-week trial, and I'm already halfway done. And I would still like to use some of the features which I haven't tried. So for instance, cursor has this way of asking a given model. I was looking at some benchmarks and I heard that O1 Mini is the best for code generation, supposedly. Right ahead of Claude Sonnet. So I am going to check this out today. So I've been trying to use cursor to do actual code generation, but this is just so... It broke more things that it fixed. It was like wasting more time than it saved. Okay, this is our current to-do list. Okay, so we have this crash in macro recorder. I would like to see.
There's a guy who uses one AI to generate high-low plan for second AI to gen code for third AI to review. Only then he reviews the code. Saves debugging time.
Yeah, I would like to use something like that. I don't want to waste time to set up a system like that myself, because like setting and maintaining this system would probably take more time than it's worth it. But I think it's like the Devin stuff, right? Devin stuff could be useful. I guess it could be handling some issues already, especially in this architecture that you describe. I also heard some things about the O1, this new model. I know that OpenAI does a lot of marketing, and a lot of this is bullshit, but they say that O1 has a different architecture and it uses some intermediate... It's supposed to be something better than chain of thought, some internal reasoning before giving you the answer. But something better than just generating some hidden tokens. Okay, this is crazy. This is a debug build. So this is supposed to run at the new rendering architecture. It really makes it fast. I mean, just look at that. It looks like 60 FPS. Oh, there are some glitches. So objects can be laggy, right? But the whole system still works fast.
Why is macro recorder a bird?
Well, it's parroting what you're doing, right? Okay, there is our error. So we have a parent, which is null. Okay, that makes sense. We are probably initializing stuff. We should initialize stuff better. What is W? What is W? Location. I suppose this is the location that holds maybe the newly created key object. So macro recorder creates a bunch of objects when I press the key, and I guess they are not properly initialized. Okay, record key event. Let's follow this function. Okay, so we have this find or create timeline. This seems to work. If this is a new key, I mean this key was not pressed before. Okay, so this is where we are creating the... So I think this is the location which has empty parent. Yep. So here we are creating empty location. I guess location gets a parent reference in the constructor. Okay, so this is initialized properly. I think this should fix plenty of issues, especially when we are starting the execution. I want terminal. Okay, there is some fun issue here. Those connections are way too long. Let's fix them as well. We've been here, right? Okay, so here we have a piece of code that actually, so this widget here, it has several places where connections can attach, from left, from top, and from right. I see some bugs. Okay, and there is, the connection is disappearing when we are here. Okay, I think I guess where the issue could be coming from. What are we doing with the coordinates? So this is the position where the argument wants to start. So this is the position of this here in local coordinate space. The parent's machine coordinates. Oh. Yeah, we should just replace this with Maybe this will fix it. And the connections, they shouldn't be invisible. They should only be invisible if we are overlapping with timeline. So I think the code which actually handles the connection visibility, I think it doesn't account for the location of this object. But we fixed a bunch of code already, so let's submit this. Time is not used directly. Okay, and this fixes positioning of new keys. Okay, so this file is where we are deciding whether to show or hide connections. Overlapping, yep. Okay, this is the line which is causing the issue. From shape. Okay, so from shape is using the global coordinates. It would be nice to introduce some tagging for coordinates. I think this would remove a bunch of issues. But I'm a little bit worried not to complicate the code too much. So we could tag every position with coordinate system that it's using. That would eliminate the situations where we compare stuff with different coordinate systems.
Automate a game that writes code for itself.
I mean, we just need an object which contains like Ollama connection, right? Like one object which connects to Ollama and another object which accesses the files, the source files, and maybe the compiler. And yeah, then we can build something like Devin within AUTOMAT. So from shape. From shape modifies itself. Okay, 2 points. Let's look at 2 points. So 2 points apparently also should have correct coordinates. I will try this with a debugger. Are we building stuff? No, we are not. Come on. We should ask O1 to do some stuff for us. I shouldn't be doing everything manually. Maybe we can try to ask it here. No. What happened? Okay, let's print some values.
Was the circle jumping around distracting at first?
You mean the eye tracker or the bullseye? Oh, I don't see the circle. It's handled by a script. So it's only composited in OBS.
Is an eye tracker of yours? Oh, makes sense. I thought of its AI feature.
We could do some AI features.
Tells you where to look.
So, my wife is doing a PhD working on eye tracking, right? And she's doing stuff like that. So on the top you can see a video, and there are some crosses here. They are barely visible, but it shows where people are looking. And those are this is the heat map, kind of like, which tries to predict where people will look. So this is like eye tracking, but without eye tracker. It tries to predict where you will look without using any hardware. It's purely computational.
Based on image?
On image movement, there are plenty of features that go into this. So, contrast, motion, faces, hands, text, there are like lots of things that influence where people will look. And oh yeah, I broke the music.
Or based on camera 2. Okay, that's great, project.
None of this is still as good as an actual eye tracker, which actually tells you where you are looking, but if you want to do something like foveated rendering, then saliency map is enough to help you do that properly. We could use something like that, by the way, because we have the frame packing algorithm. So if we had some saliency estimates, like the probability that the user is looking at a given widget, we could prioritize widgets which are most likely to be, used by the user right now. Jesus.
Imagine mapping control to you, smiling.
Yeah, I guess there are things like that. The stuff for VTubers, there is software for VTubers that actually uses camera to animate the on-screen character. Okay, so this 2-point. Okay, I will disable this breakpoint for now and resume execution. What? Segmentation fault? Ah, okay, we have another bug. Okay, this was actually nice. Okay, let me restart debugging. Another bug. In the timer thread. Huh. Oh yeah, this should never be unique pointer. This should be make shared, because it's an object. Actually, that makes me wonder. Okay, debuggers are so nice to have. They catch so many bugs. Timeline run button doesn't have a parent. Okay. Yeah, it happens because the rendering is slow. Normally we would update parents from the main rendering loop. Here we are creating a new object. I think this should help a lot. Come on. Stop debugging. That's enough. I really want to ask O1 to do some work for us, but I don't know what could it be. Something not too hard. Something that would...
Tests.
We still have a bug. Huh. Okay, let's go up. Okay, what's the issue here?
64 BBD.3 though. Why so many?
So I actually have this plan with AUTOMAT to avoid using hard drive as much as possible and to keep everything in RAM. You know, a couple of years ago we had this, early days of, for example, Linux, when a single ISO took like a CD-ROM, like a full CD-ROM. The whole system would fit in 700 megabytes. Then we went to 4 gigabytes, right? For a full like Linux distribution. And now it seems like most PCs have more RAM and memory than that. And I guess it would make sense to have a whole operating system that fits in just RAM and memory. That on startup just reads everything, puts everything in RAM, and just doesn't use disk at all. only when you actually want to update the operating system, only then it would actually write the next version, or when you are closing it, right, for persistence. It would save some data to hard drive. But the idea would be that this is my ideal kind of computer architecture, where you keep everything in RAM, you don't use disk as much as possible.
Yes, my mom's work laptop has 12 and runs Winton.
I think 2 GB should be enough. Maybe 1 GB even.
There's Antix Linux that supports that. Tailso's. Alpine runs from RAM pool.
Yeah. On Windows, I think using disk creates all sorts of problems, and I don't think we will need it in the future as much. The current operating systems still hang on to disks because they have been developed in this small RAM world, but the small RAM world is coming to an end. It ended already. It's just people haven't switched yet to like fully in RAM yet.
I don't see why disks create problems.
Oh, latency. Every kind of operation requires you to wait for like milliseconds to finish. Linux tries to hide this because Linux has this in-memory layer that separates programs from the hard drive. Not hard drive, like from disks. But it's not an elegant solution to the problem. I think the proper solution is to design programs that don't use disk, that only use disk when they actually need to use it for persistence. Like even files. Plenty of files that we save, I don't think should really be saved to drive. Like, for example, your downloads folder, you know, where you download everything from the internet. I think this stuff should be just discarded when you reboot the PC, unless you explicitly save this. I don't know, it's just an idea. I think it's going to be interesting. But the main reason is latency. File system is the main mechanism for programs to communicate with each other. You open one program, you save a file, you open this in another program, and then you edit it. And then, you know, this continues. This should really be done in RAM. Like from the, this is a very kind of high level. It's not a very specific complaint, but I think using disks, it's very limiting. It creates unnecessary latency and slowness between programs. So I think operating system and a set of programs designed to work together using RAM, memory, as the place where they exchange information, and avoiding the use of hard drives as much as possible, I think this would produce a really nice, kind of convenient place to work.
I'd hope it already happens.
I mean, hopefully it happens with AUTOMAT. So there is also this article online. Hey Dana. So there is this article called Out of the Tar Pit.
I read and forgot it.
Yeah, so the TLDR is that we shouldn't use variables. That's the gist of this article, that instead of using variables, we should like not avoid variables because they are necessary, they store data, right? But that we should have only single source of truth in a system and everything else should be computed from this single source of truth. And when we compute something, we shouldn't store a copy of the same information in other places, because this is where conflicts come from. I mean, you computed something, then you forgot to, update the information. Like if you have just one single place where ground truth is stored, you can always know which place to update. And when you update it, you can be pretty confident that all of the places are in sync immediately. So it causes this state. They want to avoid state. It's a very lengthy paper, but this is basically the main takeaway. They could write the whole paper on a single page, but then, the paper is actually has some issues. For example, it uses this idea of ideal world, right? And this is like one of the problems, because they say that, let's imagine we have an ideal world where computers are infinitely fast. And if computers are infinitely fast, then we don't need to store any redundant data, because we can always recompute this data from the single source of truth. Yeah, state in the ideal world. But they are kind of confusing those two things, because real world is not ideal world. The solution from the ideal world in real world is terrible, because it's terribly slow. Because the solution from the ideal world is just wasteful in real world. And they do this sophisticated trick of calling something ideal world, then coming up with a solution in the ideal world, and then they say, oh, this is the ideal solution. But the thing is, the ideal solution is actually, this is the worst possible way to write a program, I mean in real world. Assuming that you have infinitely fast PC, writing a program for the infinitely fast PC and saying that, hey, this is the ideal architecture. This is not the ideal architecture, this is just a rhetorical trick to call something ideal. I think a lot of people who read this paper were kind of captivated by this trick. It doesn't matter, the trick is actually the thing that I like the least about this paper. It shouldn't be doing those. This is just manipulation. The takeaway from the article, it still holds. It's still a good idea to avoid state as much as possible. It's a good paper. about architecture design, like the design of programming system, like no, design of anything. Like if you're programming, this is a good article with some good tricks of how to design stuff. It's just using some bad rhetorical tricks, which I don't support. Okay, so this, let's see. Do we have a weak pointer? We do. $540, and the weak pointer is correct. Sorry, what happened here? Oh yeah, we moved this out. Yeah, this is silly. This is my mistake. C++ should check this kind of stuff, right? This is the classical... So I'm trying to use C++ in the same way that you would write in Rust. So I'm like releasing, like moving the reference out, handing it off. Okay, so we have some key objects here, and they should be connected to this timeline, but they are thinking that they are overlapping the timeline, so they are not being displayed. And this is the breakpoint that we are interested in. So this is the key presser. For key S. So this is the key presser that we are drawing. And the 2 point has those coordinates. Hmm. 3.6. That could be cosinus 0 sinus. Okay, so this is probably the point on top of the key presser. And it actually looks fine. The coordinates of this point, I mean. All of the 2 points. I can actually inspect them here. Yep, they are separated by 8 millimeters. And 8 millimeters is the width of the key, so they look like they are in their proper positions. From shape, from shape is broken. Okay, this is very strange. Because we are actually transforming this. Oh no, we are not. We should use from. From object. Yes. Yeah. Okay, I think that was the issue. Okay. It's working. So when I have this object, when it's over the timeline, the connection hides itself. Nice. Okay, so it seems we fixed the timeline. Can I play this? No. It crashes when I play it. But we can submit those things. Okay, so we had a bug in when playing back the keys. Let me investigate this. So I have a macro recorder, I record some keys, then I play them back. Okay. And we again see the parent hierarchy being broken. Where now? It is good that we are finding those things. What? Window? I could reverse this if it's kind of messy, but path should be empty. This looks like a concurrency issue, honestly. Okay, timer thread is sleeping, right? Okay, we are in AUTOMAT loop. What is the main thread doing? Aha, it's doing stuff. Yes, so we have two threads in the update path function. And they are accessing the same data. Nice, so a concurrency issue. Okay, so what should we do? Okay, we don't need this run on AUTOMAT thread. This is completely unnecessary now. I should remove this function. It's just slowing things down. But even if I remove this function, it's still going to run on the timer thread, because timer thread, I guess, invoked it. So actually...
Do you use shared memory for concurrency?
I use everything for concurrency. There are mutexes, atomics, queues.
Never touched it, X.
It's fun. The only downside is that a thread which uses concurrency, okay, this is my heuristic, on average runs twice as slow as a single-threaded, a purely single-threaded optimized algorithm. So we get some speed by using concurrency, but we are also losing some speed because we are doing constant locking and unlocking. Okay, so we're in this key up. Yeah, I don't want to use the automat loop. That's the first thing. But this should really be called by main thread. So we shouldn't do any locking here. Let's remove them.
Low pass effect.
This is a strange function. I don't think we need that anymore. The draw function should always be executed on the main thread, not on automat thread. There was a bunch of pointless multi-threading here. Okay, those two functions, they may be useful in the future, so I will keep them. I'm afraid to remove this one. We haven't fixed our bug, but let's try again. I just cleaned up some of the state. Come on, redraw. Okay. So this is a sequence of keystrokes. Let's play this back. So we did simplify some things. It doesn't seem to be crashing now. So I created a loop which is going to constantly press those buttons. We can just see if it crashes eventually. Actually, I'll make a short break. And we'll see if it crashes in the meantime. Be right back. Cool, seems to work. We still have plenty of things to fix here. But at least that thing is working. Time to submit, I guess. Oh, and this. Let's check the other objects. All of the objects should work. So this is not the debug build anymore. So this is our timer. Timer seems to work. Then we have flip-flop. Seems to work. Then we have a hotkey. Let's connect hotkey. hotkey to the switch. It could be F3. Okay, we should invalidate the button when the key is pressed. Right. Release grab. Let's find the release grab. Shortcut button. So when the key is being drawn, okay, we are checking if hotkey selector has value. So whenever we assign to this, we should invalidate. Yeah, draw cache. Didn't fix itself. So we call this release. And we call release grab. And then we go here. That invalidation didn't work. I wonder what's the thread that this is called on. Okay, this is main thread. The shortcut button. It's already invalidated. Okay, so invalidation is at max now. If I step over, okay, now it has a reasonable value, so it should be included theoretically in the next draw. Let's go to renderer now, pack frame. This is irrelevant.
Standby Costume says,
Cheap viewers on Streamroom. Com remove the space Pinyazoroidon tool.
our hotkey has been invalidated now. I want to see if it's included in the render. So let's continue. We are hitting this point. I think I should print numbers next to those 3 entries. Let's do it like that. Hotkey, okay. So this is our hotkey. Our hotkey has index 3. And it should have a bunch of children. Three. Verdict unknown, okay. Oops. Okay, we have a bunch of keys here. One of them is the shortcut button. Okay, so here is the first loop, which tries to pack the widgets. I would like to skip to the end here, for example, and see which widgets we are packing. The verdict is still unknown. Four is overflow. Six unknown. Okay, I think this is the shortcut button. I think this is the first child. We had visit children here. Actually, no, this should be the last. But it seems like this is the one. So we are actually scheduling it in the overflow phase. hotkey itself it has a parent. I mean a texture. Actually, when I press a key, the numbers update. So we are redrawing this thing. Okay, so maybe the issue is elsewhere. Let's look at the draw function here. So we are changing the foreground color. But I think button has a separate update function, and this is where foreground is okay. It's updated. Let's actually. Yeah, I know the issue now. Stop the bugger. All the logic update should happen in the update function. Which only takes in a timer. Cool. The color is changing now. Let's see if this works. Let's hook it up to F1 and to a switch. Yeah, I can switch it on and off. This one seems to work. We did play with it already. It's just... Okay, actually this one also needs update function. Yep, and there we go. Let's continue checking the widgets. We also have the mouse. So let's say we will press the mouse down, wait 5 seconds and release it. Let's see if I can drag the window. So when the timer finishes, it should press the mouse for me. Cool. And after 5 seconds, it should release it. Cool. Something weird happened there, but I have no idea what's that. We definitely have bugs in the connector and drawing. Next we have this. So theoretically I should be able to okay. I have some trouble dragging the connection here. I don't know why. Why is the connection here? Okay, those connections, let's temporarily forget about them. Let's imagine they don't exist. Okay, but clicking the buttons on the number input crashes AUTOMAT. So this is something we should fix. What happened there? Okay. It was just very slow to render, I see. Come on. Okay, that's actually an interesting thing. It seems like grabbing an object and dropping it. Okay, now it worked. But there was a bug there. Okay, so pressing a button doesn't actually invalidate the text entry. I pressed a sequence of buttons. Whew. Some of those things are just very, very strange. When any of the digits is activated, change the text and we do the invalidation. On the release version, things seem to be working better, but this is probably lucky here. There is definitely an issue somewhere. some reason this key thinks it's very slow to render. And this as well. And some of them have negative. Okay, no, they don't. So there is an issue with time estimation here. Huh. So sometimes this render time, yeah, like here, it jumps to some very high value. I wonder why is that? Like now, I just pointed to a widget, it was invalidated, it re-rendered itself. For some reason though, it thinks that it took more than a second to render, which is wrong. This has to be caused by the renderer. So this is where we are computing the render times. So we have 2 times GPU started and CPU started. Okay, let's go. This stuff is just crazy. Maybe we are not initializing those values. Okay, no, but we do. This is initialized here. This should be seconds. Oops. Okay, we got one that took 3 seconds to render. I want to see where this time comes from. I will disable this breakpoint for now. Stay on top, please. I can easily trigger this situation. Come on. It stopped happening when I enabled the breakpoint. There we go. CPU time was 1 millisecond and GPU time, for some reason, okay, once the GPU started, freeform. I think that maybe this wasn't called. Who knows? Let's do it like that. So when this function runs, I will actually store a special value here. Minimum, exactly. And this is how we will know what's happening. Let's restart. Whoa, look at that. Once we start checking for uninitialized values, funny things start happening. I wonder why it's still running. I will just run it and close it quickly. Hopefully that will be enough. Okay, this is weird because it seems like finished proc was called before submitted proc. If the flash call fails and nothing gets submitted, the finished proc is called immediately. Why would anything fail? Success is true. Okay, apparently it is possible that Skia reorders those commands. So at the end of render frame, we have two submits. The first happens here. I want to see when the issue happens. This will spam the console a lot, so we have to very quickly close AUTOMAT. Okay, I was too slow. Okay. Okay, so we are starting rendering. This is the first frame being rendered. We are packing the frame first. For this, we should have this, which does nothing. Here we have some noise, more noise. So after that, the first frame got submitted. And during this first frame, we actually rendered the whole scene. Then we are rendering overflow from the previous frame. There should be no overflow really. But after we return, this power button again, it finishes too early. Did I close it in time? I was too slow. Oh, maybe... Let's do that. It should stop automatically. Now, after we have a packed frame, let's print all of the widgets which are in the overflow and which finished. Okay, the names are kind of messy. I need to implement this function here, demangling. Okay, this is something that Copilot actually should be able to write. So let's ask it to generate. think this should be enough. Generate. So this is the big test for 1. That's not it. Sorry, reject. Okay, so we are going forward, looking for digits. We are parsing a sequence of digits. That doesn't make sense. This will take the namespace name. I think it's trying to emulate the coding style that I used above, but it's just not doing this very well. Let's try something else. 01 preview. Let's try this 01 preview now. Okay, let's try cursor small. Okay, not bad. It's just doing random things. That's not what we want. Let's check GPT-4o. Again, this is not correct because we can have numbers in our type name. Sorry, nope. And now let's try Claude Sonnet, supposedly the best one. Okay. This is almost correct. Comments are nice. It it shouldn't really skip this completely. It should actually use this number. Okay, that was very close. And this is something we can actually rework so that it actually works. Or maybe not. Okay, apparently that was too hard. Maybe here we could skip those initial components. Okay, now this is nice. Get the length. Okay, the length can be longer than 1 digit. Looks good. Accept. Okay. We successfully used Claude to write this. However, I'm not sure if it was actually faster than if we wrote this ourselves. Okay, now we get nice names, like those. There are some bugs. Let's remove the suffix earlier. We still have those issues here. Honestly, this looks good now. Okay, we should actually do hey.
Knight says,
Hi everyone, down at BBL. It's my name's...
have no idea why the TTS messes up your voice. Okay, I think this should work now. So we have our own debunging.
Hi everyone.
Yeah, apparently putting a dot helps. Okay, now we can actually investigate what's happening when we render the frame. So, finished since last frame, empty, packed widgets, everything. Nothing goes to overflow. Then we submit everything. Actually, I expected some of the rendering to finish here, or here at the least. It's impossible that we are entering frame 3 before finishing the widgets. Okay. You know what, I will make some break and I'll be back in half an hour. I need to grab some food. Okay, so I will be right back in half an hour. I just wanted to finish frame numbering so that we see correct frame numbers. So I would expect most of the rendering to finish here, like in the between those two. Oh well. See you soon. Okay, let's analyze what's happening here. So we are rendering the second frame. A bunch of widgets finished rendering, and we are packing a few extra. Flip-flop button, then flip-flop, prototype button. Okay, for some reason flip-flop, it seems it was animating initially, because it shouldn't be rendered in the second frame. And the delay is also apparently animating. But okay, everything was packed. And then we are starting to render it, and somehow finished is being invoked before submit. We need to understand this. This is probably, there must be a bug somewhere, and this bug is probably inflating the rendering times. I mean, it was inflating rendering times. Now we are actually using infinity. So the issue definitely happens in the second frame. The first one seems perfect. Actually, instead of logging those values, we could serialize them, like we could print them into some global string, and then we would print this string, for example, at the start of frame. Yeah, let's do that. like this frame packing because it has a lock here. I actually wonder, maybe there is a concurrency issue somewhere. Right, I have a request. I'm calling this. This is synchronized, nice. But widgets. They're actually modifying this queue. They're adding themselves there. I think we should like atomically copy this out. I think this should be equivalent to calling clear. Okay, and when we are doing that, we can also do this within pack frame. And let's see our first 10 frames. Okay, so this is our widget tree. First frame, so nothing was finished. We are packing everything. Nothing is in the overflow. We're calling submit here. Okay, and we are probably getting some of those events now. Then the second submit, and the result should contain everything. We always have first submit, then finish. Submit toolbar, finish toolbar. Okay, finished since last frame everything. Yep. Those are the same objects which got finished here. Window, window. Next we are packing the same objects as before. Or actually more, because we have flip-flop button and hotkey. Nothing is in the overflow. And then something weird happens. Submit finished. Submit. And then we have a submit of the prototype button. Finished flip-flop, finished prototype, okay. The ordering looks good. This is weird. Why is this reordered? space at the end. Okay. The same issue, it's good that it's reproducible. I forgot about spaces here. The fun thing is this begin submit and then submit, they are completely irrelevant. They happen after everything was already rendered. Which is nice. Okay, we are packing a couple of widgets. Nothing in the overflow, and the error happens. Okay, so the issue, I guess, happens in the flash. Okay, frame 1 looks good. Frame 2. We have a lot of events, but that frame looks good. Then we are packing those widgets, and this is when the issue happens. Okay, so for example, the flip-flop button was submitted during its own flash, but it finished during the flashing of flip-flop. And then we get submit for flip-flop and flash. And then we are flashing the prototype button. We get submit, and now we start flashing the toolbar. And we get finish event for flip-flop, for prototype button. And for toolbar, but it happens before submit. Huh. I guess Skia doesn't guarantee the ordering of those functions, so it's possible that finish is called before submit if they are part of the same flash operation. That's my guess. I mean, it says that they are not being sent to the GPU, but I think they are. Because our submit commands are actually executed at the end. So I don't think this documentation is entirely correct. Okay, so I guess the fix will be to in finished proc, if GPU time is set to this, then we have to assume that the widget was rendered like immediately. We need to think about state transitions here. Okay, I'm still not entirely sure why finished is being called before submit. It looks like it always happens during the same flash operation though. Okay, I think the finished proc needs to somehow send a signal to the submitted proc to tell it that it shouldn't update the GPU started. Just another guard value. Here we kind of have to assume that the rendering finished immediately. And here, if Okay, some weird things are happening. Okay, weird things are happening. Okay, so this is an error actually. Here, this should never happen still. If the value is set to minimum, the previous point applies. But when it's set to maximum, we need to still run, so let's set the GPU time to 0 here. And when this happens, actually don't know what's the recovery from here. Maybe nothing. Okay, now we are printing a lot of noise to the console. But we should have no errors here. Frame 2. Yeah. It seems we fixed part of it. Okay, so the rendering times are decent here. Measured in microseconds, not milliseconds even. And this looks like it's working fine. Now let's try the debug build. Still print stuff that takes more than a second to render. Apparently this just doesn't happen anymore. It's strange that there is such a large delay before the timer is rendered. Even though each of those widgets is very fast to render. I think there is something broken in quitting now. Oops. Okay, the debug build is interesting because here are interesting things. Not elsewhere. Not in the release build, they don't seem to happen. This rendering slowness, for instance. Why is it so slow? Right now, it took so much time. Again, it's like 1 second delay before we see the results. Even in the debug build it should look better. What if I create more of those? It seems like this connection widget is packed always. everything else, it's so weird. But I think if we manage to fix this issue, a large source of latency is going to go away. If they are so slow to render, then why those times here are so low? Okay, I see that the toolbar for some reason keeps animating. Maybe the toolbar is, or some objects within the toolbar are hogging the rendering. I'm looking for any animating objects. I don't see any. Maybe if I make the window even wider. Okay, now the toolbar is not animating anymore. The latency seems a little bit better now. It's still very slow. I have an idea, but I'm not sure if it's going to be super readable. I think it would be nice if we somehow showed which widgets are currently in the queue, or how the queue looks like. This is something we can only print on the screen here. Or actually, if we go to our renderer, right, we see packing. Close this packing. Okay, so we are rendering all of the widgets which are part of the frame. This is the bullseye, let's ignore that. And then we do the present. And then we do render overflow. So I think it's possible that we are just never rendering them. And I think in order for our architecture to work, we kind of need to render stuff in the background. It needs to be guaranteed that we render at least some of the overflow stuff. Let's refresh it. I think the reason for high latency may have been that we just had too many objects on screen and the overflow never got a chance to be scheduled. Okay, so the delay is actually not a problem. The delay is fine. If I do this, eventually we are rendering it with the correct contents. So like it's the fault of the slow PC that there are lags, like on the debug build. The debug build is incredibly slow, so there is nothing we can do to actually force it to render faster. We just can do more clever frame packing. So if there is something in the queue, we will render at least once. And then we are actually not interested in the paint time so far, but I think this is draw time. Actually, no, not draw time. We care about average draw millis. Because we want to end before 16 milliseconds. This is arbitrary. I'm just looking at those times here. Still kind of slow. we are not really redrawing the... I mean, we shouldn't be redrawing this timer at all. Okay, I can still, I think, improve the rendering loop. So when we are rendering the overflow, instead of doing break here, we could actually iterate over this. What's that? Let's see. So I'm trying to fully, like, if there are any widgets that can be rendered very quickly, we will render them like as soon as we can.
Self-destructive explosion says,
Cheap viewers on Streamroom.
Okay, I think render time is better now. I don't know why render time is so high here. We're not rendering anything. Oh no, the toolbar is being rendered. Why? Why is toolbar being re-rendered? I think I know why we are re-rendering this object. It's because when I move it left, my cursor enters the button and it starts like increasing in brightness. And this causes the whole widget to be invalidated. This is interesting. So this shouldn't happen because when we move the cursor, I think we should first update the move action and then update the path, like update the currently hovered widget. So there is plenty of very subtle issues here. But okay, I think we improved the rendering latency a lot with this change, in the debug build, at least. So we could introduce some extra like time padding here, because those 16 milliseconds, there is some overhead that I think we could account for, like rendering the bullseye, for instance, or the FPS counter, or there is probably some overheads that we are not accounting for here. This is why the debug build is not hitting stable 60 frames per second. Oh, but in the release build, now we should be flying. Yeah, it's even hard to see. The pixelation. I think when we improved the time estimation, this helped a lot because we are now packing more widgets into the frame. We can be more aggressive with packing frame now because we have better time estimates. And when we have some time left in the frame, and most of the time we do, we can just render more stuff. Even with a slow widget like this one. Yeah, we're much better at squeezing more work into the frame.
Pure Kept Zero says,
What changed?
So, two things. First of all, we had a bug in... So, when we render a widget, we measure two times. First, we measure the CPU time, how long it takes for us between when we start recording the drawing commands and before we... like CPU time, before when we flash them to the GPU. And on the GPU side, we also have those two handlers. First one is called when we submit the drawing commands to the GPU, and then when we finish the work on the GPU. And there was, I would call this a bug, but okay, Skia doesn't promise that they will be called in sequence. Skia sometimes was telling us that the drawing finished before it was submitted. Yeah, there is a comment here about that. So we added some code to handle this case. So when those two operations are reordered, it generally means that the widget was rendered instantly, that the GPU is so fast that, yeah, it's basically CPU only. The CPU time is the dominant one. So that was one. And that bug, this was causing us to greatly overestimate the rendering time for widgets. Because we were overestimating the rendering time, whenever we were packing frame, we were reluctant to pack too many widgets in a single frame to achieve 60 FPS, which was causing, the widgets to render in the background, and then they were rendering with a delay, pixelated, and so on. So this improved the rendering quite a lot. And then, when we are rendering the background jobs, so after the frame is rendered, now we guarantee that at least one background job is going to finish before the next frame starts. So this is one. And two, if the current job would take too much time, okay, then we should actually not break, continue. Yeah, this is what we should do. Then we skip to the other jobs. We are basically rendering whatever we can to fit, that fits in the 16 millisecond budget, including any overflow. So if I add a bunch of those, bunch, we will basically fill the whole 16 milliseconds with as many of those as we can. It's hard to see because this is the optimized build, but there is a slight pixelation on some of the widgets. Yeah, so I think we had this issue on the debug build because the debug build is incredibly slow. Let me stop and start the debug again. Debug build is incredibly slow. It's possible that frame will never render in 16 milliseconds. And we will be accumulating background jobs without ever completing any of them. It's still laggy, but I think this is something we can fix now.
Why do you need to guarantee finishing of background jobs? There is one.
Yeah. Yeah, because if the time is constantly above 60 milliseconds, like now, when I zoom in, for instance, they would never re-render at a proper resolution. Now they are glitchy, but eventually they get updated. Like before this optimize, so I'm running at almost 60 FPS now in debug build, which is you probably haven't seen this before, but it was really bad before. It was rendering like 5 frames per second. And now we can actually use this.
I see. It skips frames but renders at least.
Yeah. We could improve this even more. There are so many opportunities here. Because this rendering approach is very different than the traditional one used by games and applications. It's very asynchronous, extremely asynchronous. And we are the crazy thing is that we are not even using the multi-threading at all. We're emulating kind of multi-threading right now. We're still rendering everything on one thread. Once we actually split this, the CPU time, yeah, is going to get really nice. We still haven't fixed this issue here. The connection. Okay, I want to submit whatever we've implemented so far.
Looks snazzy in release build. The connection.
Yeah. And the crazy thing is there is a bug in the connection still. We still haven't fixed it because on every frame we are compiling a shader. So this should actually be the fraction of this time once we remove the shader compilation. I'm just not removing the shader compilation because it's a challenge to make everything fast while still having this bug. Quite a lot of bugs.
I'm curious what you use to simulate cable physics.
I think in the docs we have this cable playground. Okay. Yeah. So on automat.org there is a hidden page called Cable Playground that actually contains our cable simulation. This is roughly how the cable works.
Says, hello, Kick Pep Zero. This is a reminder that TTS only works in English. Please use English in chat. Thank you. Copep Zero says,
Okay, I'll read.
Sorry, this is my Polish detector. It's still not perfect. I have no idea why it thought in JS was Polish. Anyway, the script isn't long here. This is... So the general trick, like this technique, is called inverse kinematics.
Patrick Novak says,
Are you also working as a programmer?
I used to be a security engineer. So I used to work on reverse engineering software. And not only reverse engineering, like fighting bots mostly. Yeah, this is a very cool trick. It's like the most basic physics simulation. So most of the physics simulations are actually computationally expensive because you have to do those collisions. So this is a very narrow, let's say, section of physics simulation where each kind of node on the list only interacts with the nodes that it is connected to. And because of that, those inverse kinematics simulations are incredibly fast. And they don't need a separate physics engine because they are completely like isolated. They are kind of self-contained. Yeah, so this is what we are using to draw nice cables. It's a very fast and also nice looking effect.
Hugh says,
Yep, that.
The stuff that I showed you on the website, this is like super complicated version, like because we've been adding a ton of weird features there. Inverse kinematics in the most minimal version is just incredibly simple. It's just one loop at the end of simulation, which updates the position of everything. Okay. Cool. So, what else do we have to do here? Okay, we fixed the crashing. Nothing was crashing. Now we want to fix the deletion of objects. Okay. So let's do that. So when we have a timer, for instance, when I grab this and throw it in the trash, or here, It's not really deleted. It's still there. I can even connect it to something. Not to itself though. So the way we delete objects is that when we press them, we create this drag widget action. And this object, where is it constructed? Here. It gets a shared pointer to the location, right? And this shared pointer is now owned by the drag action. So as long as we are dragging the object, it's alive. But then, okay, sometimes we finish the action by just dropping the object. If we can find drop target, then we move the location there, so we can return the object back to its parent. So we are stealing the object from the root machine, and here we are dropping it back. It's returned. So many glitches with connection. So I think when we drop it in the trash, we are just not executing this if condition. So theoretically, the widget should go away. But I guess there is still some reference to the location. Okay, let's find the distractor here. So the issue is caused by the fact that we are using shared pointers to point at parents in the widget tree. So even though the widget, like the object, is not really reachable from the root, it's still reachable from, there is a cycle of reference counted references. I think this is what we should do. Let's create a new function here. It's going to be a virtual function. Maybe after clone. Or not. Doesn't matter. Maybe destroy is the bad name. But okay, the story is as follows. We could call this forget parents. This would probably be a better name. Yep. We probably have more of those issues in other places. This is a memory leak. This is the most common memory leak in Python language, because Python also uses reference counting. Let's see. Yo. managed to delete stuff. Let's actually do it like that. That's going to be fun, right? Nice. We get some warnings about widget not found, but that's nice. And this is because the client probably finished rendering something. Yeah. What's that? Okay. We should probably invalidate the connection. So when the object gets deleted, this connection should be invalidated. I can move the screen around. Yep. Okay, so we are deleting the connections. Here we have a distractor for the connection. We are notifying the object that the connection was removed. We were using some tricks to actually find the target object here. So we are not storing the target information anywhere, like out of the tar pit. We are recomputing it on every frame. But that makes distraction a little bit harder. I think we could move this into connection distractor. from. I'm not sure if this is entirely correct. I had this idea that there would be multiple connections per argument. Okay, now we got a proper crash. This is probably because we are modifying something while it's iterated over. So, connection destructor. Actually, don't know what's causing the issue. Let me debug. Interesting, but okay, I was actually thinking about this and I think we shouldn't change anything in the connection and location. This was actually fine. Or actually, me bring this back. We are not going to delete anything. We're just going to invalidate the draw cache. I have a theory. Let me actually see. This is wrong. It should not look like that. Well. Okay, so we are keeping the references to widgets inside a list here, our overflow. We are actually keeping them as widgets. Actually, this should not be a widget. This should be some object that contains the recording. The recording is empty. The correct way to fix this is not pretty. So this happens if I drop something in the trash very fast. If I drop something in the trash slowly, I think this case should be already fixed. Yeah. Stuff that we have implemented, we can submit. Still have a bug. Yep. Okay, how to fix this? Again, there are probably easy fixes and the correct fixes. One solution would be to use weak pointers. but this assumes that we are running on the same machine. We are rendering on the same machine as AUTOMAT is running. In reality, we should actually change this, what we are sending here. Actually, this should be identifier plus drawing commands. Or alternatively, we could pass just the identifier, and we can convert this to widget using widget find. Overflow queue actually is going to store the identifiers. U32. Widget is empty, yeah, then we just release it. Or could also do that. Okay, the widget that we are grabbing from widget find I don't think we should store it as a regular pointer. I think we should convert it into a shared one. But maybe it doesn't matter. It's only client thread anyway. Cool, issue gone. And I think we have just one thing to fix before we can actually push this to GitHub. It's late, but I think we can do it today. Then we will fix the latency for dragging the connector, those widgets. Okay, we actually implemented this already. So this is done. Okay, now we should take care of closing of Automat. Yep, this is getting stuck. Okay, we are trying to join Automat thread, and what is Automat thread doing? It's waiting for a conditional variable. I'll be right back. Okay, so one thread acquired the lock called request stop. Actually, maybe we should call this on the stop token. Let's make it global. Okay, we need C++ documentation now. Okay, apparently we need to construct not a stop token, but a stop source. Let's try again. Okay, this is a new crash. This happens in Vulkan Destroy. Nice. So we are moving forward. Sorry, what? It says there are 49 references to the GR recording context. How? Maybe the surfaces have references. Yeah, when we are clearing the locations here, I think we should do this forget parents thingy. Or maybe not root machine, maybe window. Window is just a shared pointer. So we need to forget parents for the reset to destroy it. Yeah, so the window is probably still alive at this point. Okay, maybe this will help. Come on, stop. Enough. Okay, it looks like we managed to exit now. I will restart cursor. Four. Okay, much better. But there are still 4 references to the recording context. What could those be? Nice, we can call this. It doesn't matter. Can I search process memory for pointers to this thing? Let's actually copy this. Who cares? It has to be simpler. This is audio thread. I could, by the way, call it audio thread. This weird thing, which is something related to LLDB. Another thing. And another weird thing, so many weird threads. We must have some silly reference. Root machine was not reset. Let's try again. Still 4. Maybe root location, who knows? No, that doesn't make sense. Okay, actually we can use this get widget index to identify bad widgets. Nice. They are all still alive. Huh. All of them. widget with HTML. Yeah. Why are they suddenly called widget? Come on, it used to work a moment ago. Okay. Apparently when I invoke this from widget, type ID points to a different type. Super weird. We're used to that. Okay. So the presence of all those widgets in the cache tells me that they are still alive. Attempted to dereference an invalid pointer. Huh. No, this should be 316. Yeah. Yeah, everything is still alive. unnecessary. Okay, so I am clearing all of the pointers to parents. I am not clearing the pointers to children. Let's have this root location. Maybe this is keeping everything alive. I don't think there are any shared pointers. Any extra that could keep this alive? We still get 4 references. These are not all globals. root location is empty, root machine is empty, window is empty. Okay, maybe I should have called this before clearing locations. Because this doesn't visit all of the children. That was it. And that was it. Okay, now we are properly releasing all memory before shutting down Vulkan. Nice. Oh, actually, I shouldn't do this on Windows, because on Windows, thread name is actually important. Yeah. Okay. Crash is fixed. Let's run a benchmark. I had this event bench. This is the important benchmark, the most important we have. It checks whether we are delivering events with low jitter and without any drift. Okay, let's go. For some reason, Ctrl Q did not work. Okay, now it worked. We have some drift. It's borderline acceptable. Jitter is fairly high though. Higher than we used to have. Drift is negative now. Okay, that's interesting. It doesn't look bad. It's just barely worse than 5 days ago. And it's way, way better than 3 weeks ago when we started. Cool. I think the two next things that we should take care of, I think we can push this to GitHub. Will be, first of all, we will have to fix this spamming issue. It's annoying. And the most visible glitch right now are the boundaries of the connections. Maybe this is even the first thing that we will do. Okay, so AUTOMAT is a little bit buggy now, but it's usable, I think. So I think we can push the new rendering pipeline to Git. Commit and sync. Cool. 900 commits. Should be okay. It's just building the web page. This doesn't matter. I have no idea why it's pushing the web page, even though nothing has changed in the docs directory. Cool. Okay, this is it for today. On the next stream we will fix the laggy connection rendering. Sorry, what? Okay, we have to stop this craziness. Stop, please. Okay. I said stop recording. Okay, there are still some things that we should fix, but not today. Oh crap, I submitted AUTOMAT with debugging enabled. I think if we disable debugging, the FPS should be even better. Because we're just drawing a lot of text and boxes. Completely unnecessary. I wonder why render time is so slow. We are literally compositing a single texture on screen. I think this is something to do with timeline. No, this is what's causing the slowness. Or not. It's hard to say. Whatever is happening here. Yeah, we also need to fix that. Okay. See you on Friday. Another stream probably dedicated to the new rendering pipeline.